Hi, welcome to my video on second derivative of functions, and this is number 4. Again, more examples. And the more examples you see done, the more hopefully the second derivative will become clear to you. Find y double prime of each. Y double prime is d squared y dx all squared, so it's the second derivative. So the first derivative we'll do d dx on the y, and we'll do d dx. We're doing a derivative in terms of x. Okay, here we go. And again, d dx is dy dx. And the derivative here in terms of x, derivative of ln is 1 over the function 4x cubed plus x squared. And the derivative of the inner, 4 times 3 is 12 cubed. 3 minus 1 is 2. Derivative of x squared, 1 times 2 is 2. And 2 subtract 1 is 1. And so just to change this, so we're doing, this is dy dx, so dy dx is the same as y prime. And that gives us 12x squared plus 2x all over 4x cubed plus x squared. And we can simplify that and make it easier. We could call it y prime. X is common in the top, so we have 2x is common, so we take the 2 out, and we take the x out, so that gives us 6x plus 1. And a common factor in the bottom is x squared, so that gives us 4x plus 1. So that y prime is x cancels, so I get 2 times 6x plus 1 all over x is cancelled, so the square is gone, so it's x times 4x plus 1. Now we need to do the double derivative, or y double prime. And double prime is the second derivative, so again it's d dx. So d dx, but before I do that, let's make, rather than have a product on the bottom, let's multiply that. Even though I canceled the x here, let's go 12x plus 2 all over 4x squared plus x. And that makes, when I do the derivative on this quotient rule, I don't have a product within a quotient. So let's do the second derivative on this function. So let's start here. So the derivative is dx on y prime, and it's dx on 12x plus 2 all over 4x squared plus x. And so the derivative, d dx on y prime, is y double prime. So it's d squared y dx squared. So instead of doing that, I'm just doing the y prime and y double prime. So the derivative of this quotient, so this is an f and that's a g. So without writing it all down, by now you should know how to do a quotient rule. So it's the derivative of the f on the top. So the derivative of that is 12. Derivative of 12x is 12. Derivative of constant is 0 times the g, which is the denominator, minus f, which is 12x plus 2, and derivative of the bottom, g, is 8x plus 1 all over, and that's all over g squared, so 4x plus x squared. And what does that give us? Well, if we multiply here, we get 12 times 4. We get, and this separated this way, so that gives us 48x squared plus 12x. Subtract, and now can we multiply this fast? How fast can you multiply? Let's see, the negative is here. So 12x times 8x is 96x squared. So 12x times 1 is 12x. 2 times 8x is 16. So that gives us a 20. So 16, and that's 12x. And 2 times 8 is 16. So that gives us a plus 28x. And 2 times 1 is 2. So just to make sure, yep, everything is okay. 2 all over. I'm going to leave that like that. 4x squared plus x all squared. And so that gives us, we have to do the subtraction now. So I'm going to show you that. When we subtract, we add on the opposite. So it's a negative 96x squared minus 28x minus 2 all over the denominator squared, and that gives us 48, and negative 96 is a negative 48x squared. 12 minus 28 is a negative 16x, and minus 2 all over 4x squared plus x squared. And if you want to take the x or leave it like that, but the x can come out here and be a square, and I don't have to factor. But that is the second derivative. I could simplify this a little tiny bit further. Not simplify, write it different. Probably I'll do it for you. I could take the 2 out. I don't have to, but I could take the negative 2 out and make it 24x squared plus 8x plus 1. And there's an x in here, so if I take the x out and square it, so that's an x coming out of these two, squared, so it's x squared. So the x coming out of here gives me 4x and a 1. So that's just written different, but that's the second derivative on this ln function. And a little bit of algebra involved here, but not too bad. So let's do y prime. So y prime is d dx. So the derivative here is the derivative of cos is negative sine of 2x to the 4th times the derivative of the inner is 2 times 4 is 8, and 4 decreased by 1 is 3. So y prime is negative 8x cubed sine 2x to the 4th. Okay, now what we have here is we got to do double derivative. So double derivative is, and let's see, let's go down here. Y double prime is the derivative again. So this is a constant, so we leave that constant there. So now this is an f and a g. So it's the derivative of f, which is, this is f. So that's 3x squared sine 2x to the 4th. And that's a product, so it's plus f is x cubed. And the derivative here is the same as this one. So we don't have to, so this derivative is the same as, well, almost the same. But the derivative of sine is cos 2x to the 4th times the derivative of the inner, which is 8x cubed. And so we tidy that up, and we leave the negative 8 there first. And we get here, we get 3x squared sine 2x to the 4th. And this is positive, so 8x to the 6th cos 2x to the 4th. And if you want to multiply 8 in through here, or if you want to take the x out, the depends. You can take the x out, or x squared comes out, or we can multiply the 8 in through. So it don't make any difference, whatever way you want to. You can move the 8 in through or take the x out. So we go take the x squared out. So x squared is coming out. We get a 3 sine 2x to the fourth plus 8x squared is coming out, x to the fourth cos 2x to the fourth. Again, I could have multiplied both of these by -8 and had the sum of two expressions, but it's same idea, just expressed differently. So that's the second derivative. And hope you enjoyed the video. So that brings us to the end of this video. And again, if you like my video, click the like button, click the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.